Excellent. Good day, good morning, good evening. Thank you very much for joining this webinar on the Global Power System Transformation Consortium and our experience in the first 5 years of G-PST lessons learned and accomplishments. My name is Karin Wadzak, and I am the Executive Director of the Global Power System Transformation Consortium. I've been working in electricity for over 20 years, and today I'm going to be joined by two colleagues, Gabriel Covarrubias Moreira, who is an early career researcher at the Imperial College of London. He has industry experience in electricity system modeling, and he's been participating deeply in G-PST's research activities over the last year. And then our colleague Lina Ramirez has 15 years experience in operating power systems and working on technical operational challenges. And she directs G-PST's partnerships with power system operators all around the world. So what I'm going to share today is a history of G-PST and some of our key observations over 5 years of working on power system transformation. And then Gabriel and Lina are going to talk about the technical work that we do, first from the research and then from the application perspectives. And right before we get started, I just wanted to cover a couple quick housekeeping points. We're going to plan to present for about 50 to 60 minutes, and then we'll have the balance of the time for any questions that you might have. You probably saw the calendar reservation was for 75 minutes, so if there are a lot of questions, we are definitely happy to stick around for that whole time. And all of the participants have been entered in muted and cameras off mode. And so we'll be using the Q&A function in Zoom for discussion. So at the bottom of your screen, you should see a little square that says Q&A, and you can feel free to type your questions in that box throughout the event, and then I'll be moderating our discussion after all of the other presenters are finished. And you probably heard we are recording, and we'll be posting this webinar on our website, and we'll also be sharing it in our newsletter. So we are the Global Power System Transformation Consortium. We call that G-PST. At G-PST, we envision a global community of power system operators, researchers, and practitioners that enabled every power system, regardless of its geography or its resources, to adapt to rapid technological change and to deliver reliable, secure, and affordable electricity for everybody. G-PST's mission is to remove all of the technical barriers to operating 100% inverter-based power systems. We have a peer network of operators, researchers, and practitioners working together to develop validated solutions, share replicable tools, and build trusted partnerships, all working to strengthen system operators' capability and confidence in operating highly inverter-based systems. We all know the power system is changing at an unprecedented pace, and as we're making this paradigm shift from running the electrical system predominantly on synchronous machines to power electronics, everything that we're doing at G-PST is working to keep grid operators ahead of those changes. So the way that we see it in this decade, we need to be making as much technical progress as the power system made in the entire last century. So if you're not already involved, you can get on our website and sign up on the link that we show on the screen. Originally, G-PST came together as an idea in about 2019. It was between system operators who are running the world's most highly inverter-based grids and some of the leading power system research institutions around the world. And these operators were facing unprecedented challenges, and they recognized that it is not that efficient to be working on those challenges alone. So G-PST came together initially as an alliance of 6 power system operators and 12 of the world's leading research institutions with the goal of identifying, prioritizing, and solving those technical challenges together. The way that we do this work and ensure our impact is by connecting the network, breaking down silos, enabling collaboration, and setting an intentional shared research agenda that enables renewable integration. We develop cutting-edge tools, methods, and approaches to solve problems and build technical capacity in a real-world operating context. And we scale all of that by leveraging our global network through peer exchanges and the workforce development programs that we have to accelerate and replicate solutions for operators around the world. This session is called Lessons Learned in Power Systems, so I want to talk about some of the key assumptions and some of the things we've learned. When we started, we assumed that operators are not competitors and that they have a natural basis of trust because of their shared experience. And what we've learned over the years is that operators working together can make extremely fast progress. Sometimes that requires enabling support, and it turns out a little bit of support can make a lot of difference. We also assumed operators would benefit from being able to tap into the resources available at research institutions. So basically gaining the additional time and expertise of leading researchers who are working on technical problems that operators also need to solve. And so we've learned a couple of things. One, unfortunately, it's largely true that no operator actually has all the people they need, all the resources they would like to be able to solve technical problems and stay ahead of challenges. So being able to work on those solutions together with leading researchers has proven, in fact, to be quite beneficial. But also there's a balance on how to best use system operator technical staff time on largely academic research teams or vice versa. And so we've built strategies for being judicious in how we bring those teams together and actually narrowing the gap between academia and the real world that operators are working in every day so we can deliver useful solutions faster. I mentioned we started off with 6 operators who had a vision for what G-PST could be. And so in these 5 years of our existence so far, we've had more than 36 operators that have been deeply and actively engaged in forming our agenda, in solving problems, and in sharing solutions. Across nearly 350 activities in the last 5 years, we've had participants from 69 power system operators in 136 countries. And this breadth of applicability and interest that we've observed validates a couple other points I wanted to highlight. One thing we've realized is that progress that our network is making toward our 100% inverter-based resource goal is actually helping on a number of other different fronts for the operators that we're working with. So it's not just that the farther the front runners can get, the faster everybody else can accelerate their progress, but also when we're developing new tools, those approaches that we're working on can help with tools that perform other functions that in turn help with other changes that system operators are facing. And when we implement workforce programming or build connections among operators and universities and research institutions around the world and bring in more and different people from the next generation, we're helping operators to strengthen their institutions as a whole and also to tackle all kinds of other challenges that might have nothing to do with inverters. I also wanted to note that when we're implementing programming, we are intentionally seeking out a balance in the operators we're partnering with in terms of their decarbonization status, their system topology or archetype, their geography. And that's because we've learned that a representative set of operators implementing new technical solutions can increase everyone else's confidence in getting ahead of those challenges when the time comes for them as well. Over the years, we've engaged in hundreds of activities from tool development to technical exchanges and internships and workshops and training and webinars. And we've shifted from the start of G-PST till the more recent years to activities that provide more direct capacity building, technical assistance, research solution, and tool deployment directly to system operators. And of course, all the individual projects we're performing then turn around and get fed back into our network for dissemination. But the diverse list that you're seeing here of the different kinds of activities and those changes that I just mentioned that we've made over time for how we implement our programming is also intentional because it creates this scaffolding of support, enabling operators to better address technical challenges because they have all those pieces in place. So it's not just like, here's a tool, but also there's training, there's assistance, there's long-term relationships that are critical for solving problems today and for then addressing those and developing new solutions in the future. So if you put that another way, you could say we take intentionally a multidimensional approach. When G-PST first started, the people that came together realized that yes, of course, it would be useful if you could develop cutting edge solutions together. And of course, it would be useful if you then perform technical assistance for disseminating those solutions. But it would be much more useful, many times more impactful to also support system operators in their needs for a larger and more diverse workforce, to support the development and implementation of the standards for deploying new technologies, and to promote open source tools and data for operators to use in both planning and system operations. So on top of the work that we're doing matchmaking between operators and researchers and operators and other operators, we also are very intentionally supporting these other enabling elements as a key part of G-PST's offerings. In another minute here, I'm going to be handing things off to my colleague Gabriel and then to Lena. Gabriel will be talking in depth about the G-PST research agenda. And this is the guiding document that focuses all of G-PST's work and ensures that we are solving the right problems. It's intentionally not a laundry list. It's not all the questions power system operators might want to answer or need to in their day-to-day operations. It's purposely a narrow and shared research agenda that details the most pressing and pervasive challenges that power system operators need to resolve. And it is specifically focused on the emerging topics of managing highly inverter-based power systems. When we first started G-PST, we published the initial version of this with a smaller group of operators and researchers in 2021. And then every single year, we've gone back and revisited the document to check and see if it still represents system operator priorities, if it's still covering all of the right topics. And so this past year, we updated it and published a new version. We brought together several dozen operators and a broad set of researchers, and we had folks provide input in writing, in group discussions, and at an in-person meeting in Berlin to update the document to the newly published version that you can see here. And you can also download it at the link that's provided. And the agenda is, as mentioned, covering cutting edge and emerging topics. Gabriel is going to share some information and explain a little bit more about how we're tackling those questions. And then after him, Lena, who directs our partnerships with system operators, is going to share concrete examples of implementation and solutions in each of these areas around the world. So before I hand things off, as a reminder, you can feel free to pose any questions in the Q&A section on the Zoom screen, and then we'll take some time to address any questions that there might be at the end of the session. So thank you very much for your time. I'll pass things over to Gabriel, and please take it away.
Well, thank you, Karen, for introducing me, and thank you all for being here. I'm going to share my screen, so just let me know if you can see my slides.
Looks great.
Excellent. So, well, to get started, like a very small introduction to what's the research agenda, as Karen was just mentioning. This document tries to set common grounds in what are the system operators' needs for trying to advance towards the IVR-dominated power systems. And particularly, the main aim of this document is try to redirect research efforts to develop new enablers to go through all this energy transition in power systems. And particularly, since Karen was mentioning, the very first version, the inaugural research agenda, was published in 2021, trying to solve the critical needs on power systems within a range of 10 years. And this document was mainly composed by 6 different research programs, as you can see on the right side of the slide, composed by 59 research questions. The 6 research programs were inverter-based designs, stability, tools and methods, the control room of the future, planning, system services, and restoration and black start. However, as we know, systems evolve over time, and also we had to periodically check what are the system needs and system operator challenges as well. So during these last years, G-PST has been reviewing and revisiting many times all these research questions. We're trying to see if they're really addressing the main challenges that system operators are facing nowadays. And that brings us to this point of updating the research agenda on 2025 for trying to give a new update for how the research has advanced in terms of how to solve these problems. So in a very high level, how the research agenda has changed during these years is mainly that we have initially merged 2 research programs. The inverter design and restoration are now completely absorbed by a new inverter-based resource program. The second part is that the distributed energy resources are having a new independent research program. It's important to note that in the original inaugural research agenda, many questions were addressing the DR challenges in power systems. But since DR was supposed to be more related to the distribution level, and the research agenda was trying to aim to solve transmission level or bulk system power systems, it didn't have a direct research program by its own. So now that we're having new updates and also we're trying to capture all the potential flexibilities and opportunities from DERs, it's important to get more importance at the end in the new research agenda. And finally, one of the key differences in the new research agenda is that we're trying to avoid redundancy in some questions, repetitions, and trying to give an update of what and how different research areas have advanced during these years. So many questions that were in the inaugural version are now merged. So we're start reducing the amount of questions, giving us a total of 48 research questions in the new version. And also, well, as you can see here, the 2025 research agenda is mainly composed again by 6 research programs: the IVRs, stability again, CROF, planning, services, and the DR questions. And an important point as well is that, well, even if we're trying to face and to solve the challenges from the power systems engineering perspective, it's important to acknowledge that many of these challenges are mainly related to more interdisciplinary areas. So as you can see here on the diagram, the IVR and the stability questions will have a factor that should be linked to power electronics and control theory. For trying to solve some DER and the control rooms questions, we might need some computer science, data science, and visualization techniques for trying to get like a more appropriate way of solving issues. And naturally, planning services and DRs will have an impact in terms of economics, policy, regulation, social science, and even more different aspects as well. So just to explain a little bit how this process was carried out during the last year, initially we started reaching out with the research community, trying to get their feedback from, trying to update the research questions, validate that the merging of these research questions makes sense for trying to really address the future challenges. Also, at the same time, we're trying to get their feedback for trying to update with the state of the art from different tools and solutions. Once we pass from this stage, we started reaching out also with system operators, trying to get the same feedback from trying to ground these problems to the real world and validate as well that these are the real challenges that system operators are facing and are planning to solve during the near, close, and mid-future. And we also organize roundtables with system operators and researchers as well for trying to make a consensus over the research questions. So just to illustrate a little bit how many institutions, system operators, and researchers were involved, here in the map you can see most of the different institutions that participated in the research agenda update in the 2025. And we can see different institutions from Europe, from Oceania, from Asia, and the Americas at the same time. So you can see that it wasn't just a small project with a very few people, but we also get involved more than 100 people in total in getting feedback, support, and so on. So just to get into more details of the research agenda, it is composed by the 6 research programs, the IVRs, what's trying to develop new capabilities, requirements, services, and potential design methodologies for standardizing how the IVR should behave in power systems when we're reaching high penetrations of IVRs. The stability section, that's mainly related to new tools, analytical methods for trying to solve and analyze different stability issues in power grids. The planning section as well, that's, well, naturally tries to develop planning techniques, incorporate different levels of uncertainty, different influences of different technology mixes for trying to address the reliability, be prepared for extreme weather events, but also at the same time trying to address the uncertainty that we have with different technologies that are being incorporated to our systems. The control room as well tries to give support to system operators in terms of how to visualize when there are critical situations taking place in our systems. How can we enhance and guide operators for trying to take the optimal corrective measures and trying to maintain the reliability of the system. The system services, as the 5th research program at the same time, was trying to address the system needs and at the same time trying to ensure reliability and the stability of the system while operating it at minimum cost. And finally, I was saying before, the DR section that has like a huge impact in power systems, considering all the different distributed energy resources that we have in the system, and how can we try to leverage all the flexibilities that it can provide to the grid. So all these documents, you can have all the details of each section in the website that we have, published the research agenda, and each of the research programs are mainly composed by a brief description of the state of the art, what are the initiatives that are taking place on different research programs, and then a table as the one that you are seeing here on the screen. This table is composed by the different research questions of each research program. So, for example, here in the stability research program, we have one question related to the subprogram of tools for real-time operation on IVR-dominated power systems. And the second subprogram has 4 questions related to methods for planning and operation. So mainly based on this structure, you can have this eye-catching illustration for the research agenda for each of the research programs and their respective subprograms, in which we can identify how the different research programs interact with each other. So as we were seeing before, we had the stability subprograms that are very linked to the IVR subprogram as well, naturally, because we're trying to assess within IVR-dominated systems, how the stability questions might be related to resource adequacy, at the same time as services as well to DER. So at the end, as we were expect, in a graph of a networked system, we'll have a lot of interactions within different areas. And we can see also that there's a huge center around the planning section at the same time. So after having all our roundtables and discussing with system operators and researchers, we also had the opportunity to take what are the main challenges that are facing, that they're seeing in the near future. And as an example for those, we all know that there are like a lot of like small talks and big talks about data centers and system strength, and other topics as well at the same time. So just for trying to showcase a little bit how the research agenda tries to capture these different topics, is that we're comparing here the inaugural research agenda question 47 to the new version as well, considering that, well, now, even though some of the content might be addressed by this question was already addressed, but not explicitly, now it's more explicitly for trying to be more concise as well at the same time that we'll really addressing these kind of challenges. On the other hand, we have this question 54 of the inaugural research agenda and change now to the question 34, in which we're trying to give you guide a little more specifications in terms of what we're trying to give, and also not trying to get biased technological or solutional biases towards some specific solutions. So at the end, it's trying to get everything more in the holistic view, but covering all the different areas. As well, you will find in the document different sections that tries to give some insights in different initiatives for the challenges in power systems. Specifically, there's like one specific text box called Data Centers in Power Systems, which tries to give like a very brief insights in how power systems should adequate for data centers and how data centers should start adequating for the power systems. There's also a very brief presentation of one of the state-of-the-art techniques on identification of source of oscillations in power systems with high shares of IVRs. There are some examples as well for initiatives of applications of AI or artificial intelligence, in which we are describing different initiatives around the world, but also like some potential applications of AI, such as like topology optimization as well. And finally, there's like a very holistic view on how the grid services should be designed for trying to integrate all the potential dimensions and interactions that we need to model at the same time. So just getting back to one of the initiatives as well from the G-PST, and also like motivated by this advance in the research agenda of getting an independent research program for the DER section, is that the G-PST has been working on a DER task force trying to address mostly how the DRs might have an impact in full power systems. So at the end, it's trying to get a consensus and a common language and the standardizations of how the DR should be treated in power grids in the transmission level, but also in how it should be treated for the distribution as well. So we're trying to get like common grounds for making it like what are the requirements for the visibility and flexibility? How should we aggregate the different resources and technologies? What are the architectural requirements for the technical devices? How these technologies can provide services to the grid for trying to accomplish the requirements of the system, and how also all these flexibilities can be incorporated into the uncertainty analysis for resource adequacy, for extreme events, at the end for trying to leverage all the potential utilizations of these technologies. So the task force is working on a report, and also this report is expected to be finished by June. So eventually you will want to hear back from us into more details about this report. And finally, that was all for the research agenda update, but something very important for the G-PST is not only covering some countries and some regions of this beautiful world and earth, but we'd like to color all the countries that we have here for trying to get a more complete research agenda for trying to really address the energy problems that we're facing in the world. So if you want to get involved in the G-PST, you want to take part of the different initiatives, or you want to also get in touch for what's going on with the research agenda or different initiatives or projects, just reach out to our email that is marked here in the bottom. I would like to also invite younger researchers to get involved in the different initiatives that we have. If you have a super research program or you have an idea you would like to share with the power system community, please reach out. We can give you feasibility and visibility as well for trying to get more people involved in this transition. And also, like a very small detail is that during this year, we're gonna be organizing different roundtables and discussions for the different sections of the research agenda. So we're planning to host the IVRs planning and so on for trying to get a more deeper insights in the of the art, what are the different applications, how different system operators are trying to solve the same problems, and also try to link the research community with the system operators community for trying to solve all these problems all together. So, well, that was all from my side. Thank you very much, and I'm handing it off to Lina.
Thank you, Gabriel. So I will be sharing my slides. Okay, can you see it?
Yes.
Okay, so thank you everyone for being in this call. So I am really glad to be presenting the major achievements from G-PST during the last 5 years. So I will be presenting some examples of the technical assistance and all the projects that we have been developing during the last 5 years. So I want to start to mention that it's really important for me because I started in G-PST from another side. So I was working for the system operator in Colombia 5 years ago, where I was sharing all the challenges that we had at that point with G-PST and receiving technical assistance and advice at that particular time. And 3 years ago, I had the opportunity to work directly with G-PST, leading some countries, and as well leading the partnership with all the countries around the world and working in technical assistance. So I am glad to share all this information because I start from the system operator side and now here helping several system operators, working with a great community of researchers. So it's really a pleasure to present the achievements. So as Gabriel was presenting, so we are focused in 6 areas. So he presented before where is the focus of each area. So here I will be presenting directly some examples on each area. So how we are using the research agenda, how we are like helping the system operator to solve the challenges and the questions that we have there. So I want to mention that is not everything solved, some of the questions, part of the questions. So this is some examples how we work, but we continue working in the research agenda and in the topics that Gabriel presented before. So regarding control room of the future, we have been working in several countries. So basically in almost all the continents, helping the system operators to develop the roadmap for the control room of the future. So basically how they need to improve to include more IBRs and maintaining the security and the stability of the system. Regarding planning as well, we have been working hearing the needs of the system. So what are the challenges and the problems that they are having? So basically we were regarding resource adequacy and integrated planning in some countries as India, UK, Australia, and USA. Also working with some universities. I will be presenting for each example what are the entities that are involved. So as Karin mentioned before, G-PST is a community of researchers, system operators. So I will be highlighting what are the entities and the researchers that have been working in those particular projects. Regarding stability assessment, so this is a big concern and one of the hot topics that we have regarding G-PST. So basically all the system operators are having concerns regarding stability as the system is evolving, how they can maintain the stability, and also how the new devices can help to maintain that stability as well. So we have been developing some tools and also technical requirements for IBRs, how they can help to maintain that stability. So we have some examples from Vietnam, Chile, Colombia, South Africa, Morocco, and India. Regarding IBR, so basically we have been working how the technical requirements and the standards can help to maintain the stability of the system. So how the IBRs evolve. So we have bigger IBRs and grid forming. So how we can use those capacities, so those technical capacities to improve the stability of the system. So we have been working with Chile, Brazil, and Colombia. Some are the examples that we can present today. Services, so we have been working with the system operators to understand what are the needs. So basically every system is different. So we need to understand what are the needs, what are the problems, and according to those needs and those problems, we can define what are the services that they need. What are the services that the IBR should provide to maintain those needs and to avoid the challenges that they are facing. So regarding that, we have examples for Chile, Brazil, Colombia, Pakistan, and India. And the last topic is distributed energy resources. So basically, we are working how DER are affecting the Val power system. We are not working directly in distribution. We are working more what is the impact of the DER in the Val power system, also how they can help the system to be more flexible. And we have some examples regarding Vietnam. So let's start with the control room of the future. So for that particular topic, we have been working with EPRI. So EPRI developed the control room of the future framework, and we have been applying that framework in several countries. So basically in Europe, Oceania, Latin America, Asia, US. So almost all the continents are covering, and almost all the system operators are requesting help regarding the control room of the future roadmap. So what are the capabilities that they need to improve, how they can improve the control room to be able to operate the system under the energy transition. So basically we cover what are the facilities and the equipment that they need to improve, the data and analytics that they need, applications, and human factors. So we develop those projects with the system operator. We understand what they have now, what are the challenges, and we propose what are the new topics that they need to include and how they can improve in the following years to maintain the operation in a stable way. Regarding the control room of the future as well, we have the Research Council. So basically this council is accelerating the adoption of the next generation control room. So we are working what is the best architecture, what are the tools that we need. And this particular control room of the future Research Council is led by 50Hertz, the system operator of Germany, who is helping us to evolve that control room of the future, evolve the tools, and helping other system operators across the globe to improve the control room. So basically, also, we are working in some research challenges that 50Hertz is launching. And also we have some webinars and some in-person meetings. Last year, we had one in Berlin when we were sharing all the improvements from several system operators and also how 50Hertz is managing the new generation of the control room. So how they are like proposing the new architecture for control rooms in the future. So basically with this council, we are supporting system operators worldwide in advancing real-time operation decision-making. Planning, so for planning, as I mentioned before, one of the topics that is of very interest of several system operators is resource adequacy. So we work with the system operator in India. So they had a new regulation in place where they were required to have resource adequacy studies, but at that particular point, they don't have the tools and the procedures for doing that. So they request the assistance of G-PST, and in this case, the National Laboratory of the Rockies was helping with one particular tool that is called PRAS, that is an open source tool. So we train the system operator in India how to use the tool, how to develop resource adequacy studies, and later they developed their own tool. And with that tool, they were able to define what is the unserved energy that they will have in future, and also to propose what are the studies that they need to develop, and using their own tool based on PRAS. So basically now all the system in India is using that tool, and they are having those kind of studies where they can see for the next season if they have some unserved energy or they need to solve any issues to avoid unserved energy in the levels that they don't allow. So this is like a successful case how we can use like an open source tool, adapt for a particular system as well, where we were helping to define the studies and the framework based on one new regulation that they had in place. So this is a good example, and it was like led by National Laboratory of the Rockies, and as I mentioned before, using the open source tool PRAS. Regarding planning as well, we are working with the EPIC Center. So this is the Electric Power Innovation for Carbon-Free Society. So this center is led by Johns Hopkins University, Imperial College of London, University of Melbourne, and CSIRO in Australia. So basically, with this center, we are working with several universities and research entities solving issues that the system operators are facing right now. I want to highlight here one of the examples, and is related to planning, where also now the National Laboratory of the Rockies is helping. So we are using like integrating planning using two open source tools, PRAS and also Sienna, where we can develop like resource adequacy studies, production cost studies, and dynamic studies, integrating all those studies, looking what are the problems that we see in one study, and changing to another tool to narrow that scenario and understand what is happening. So basically with these models, the universities, the students, and also the system operators are learning how to use those tools, how to have those integrated planning studies, and how to improve the planning in those systems. So we are hoping to have examples for UK, Australia, and US at the end of this year, showing how, for example, the resource adequacy studies can be used for those particular systems. So this is, as I mentioned, a cooperation between several universities, also research entities that are working together to solve the problems of the system operators. Regarding stability assessment, so I want to highlight one of the tools that we developed in Grid India. So we were helping them to learning how to use like a particular oscillation source analysis tool. And also after they understand how they can use it, they adapt that tool and create their own tool that is now used in all the control rooms in India. And it's helping them to understand if they have oscillations, to detect oscillations, and to avoid issues in the control room. So basically, this is improving the stability of the Grid India system. Some similar example is in South Africa for the system operator ESCOM. So for this particular example, we were helping, working with EPRI, the National Laboratory of the Rockies, and CSIRO. So basically, we work with the system operator in South Africa, helping them to define and develop a new tool where they can track the inertia of the system. So as the system was evolving, they were like with a need to see if they have enough inertia in their system, and we developed this tool, and they are using that in the control room. So basically with this tool, they are enhancing as well the stability and the operation in the South Africa system. Also, as we start to develop several tools, we start to understand that we need like a common framework for use like information. So last year, we started to work in one real-time phasor analytic tool. So we have the link here, and it was developed basically for the NSMO system in Vietnam, but it can be used for any system. So basically what we did here is like to have a common framework to use PMU data for using later for other kind of applications. So we realized that every system operator is using in a different way the PMU data, and it was difficult to develop one tool for all of them. So at that point, we realized that we need like a common framework. With that common framework, now we are able to have the information from the PMUs and to use that information for different applications, for example, inertia, system strain, or oscillation. So this common framework is as well in GitHub, you can use it, and is like using this moment for the system operator in Vietnam. And it was developed by the National Laboratory of the Rockies. So I want to highlight here that we are not only working with research entities, with system operators, also we are working with universities, and the idea is to help to develop like the workforce that we need for the power system. So one of the needs of almost all the system operators is to have like engineers and people that is like capable to operate the system with the current needs. So for that, we are developing training materials, also helping to have internships and to train the new researchers and the new engineers to be able to operate the power system with the current needs and with the challenges that we are having. So for this particular topic, we have been working with the National Laboratory of the Rockies, with EPRI, with Imperial College of London, and it's also integrating like more women in power systems. So we are having like some internships in EPRI, in the National Laboratory of the Rockies for the women, where they have been working in several projects that are related to system operator. So this is like a way to train them and to include more women in power system and to have like the workforce that we need for now. It's not for the coming years, it's for now. So regarding inverted belt resources, so one of the focus is grid forming. So basically it's because it's the need of all the system operators, so they want to understand how they can use grid forming, how they can help the system for the current needs as inertia, system strength. So, and basically as well, we are working how to use the IBRs to enhance the stability of the power system. So this first project is a project that we developed like for the system operator in Chile, Coordinador Eléctrico. It was like developed by the National Laboratory of the Rockies, where we compared like the technical requirements that they had for the IBRs, comparing with other grid codes in the world, like were more advanced. So we compare with the EarthGrid in Ireland, with NISUM in UK, and also with the IEEE 2800. And after that, we help them to define what are the changes that they need to improve in order to have like a better technical requirements for the IBR and support the systems, because they are having like high amount of IBRs in their systems and they are requiring more services from those IBRs. As the technology is evolving and is capable to provide those services, so we help them to develop that proposal, and is under the regulator like studies. So basically with this, we help them to enhance the system reliability. Another sample how we work in IBR. So this is basically a project that we developed with EPRI, where we were helping Coordinador Eléctrico in Chile to understand how to model like grid forming. So for having like open source models that were like identifying like the services and also the needs that they have in their system, and to identify how much they need, where they need grid forming. So basically we developed a lot of testing in that project for several open source models for grid forming. We enhanced those as well. And after that, like Coordinador Eléctrico was able to use those open source models, as they need to understand before like having those devices in their system, how they behave and how they can improve the system. So it was another particular example. At that point as well, we realized this is a project that we developed with the Energy System Integration Group, ESIC, and the National Laboratory of the Rockies, that it was important to understand what are the capabilities, the current capabilities of the grid forming. So some years ago, several system operators were thinking that grid forming is not available, that they were not like, it was research, it was not something that they can use. But now with this kind of work that we developed, they can see that is available. Several system operators across the globe are using the requirements and are having those grid formings in place for enhancing the power system. So basically we compare several grid codes and start to understand what are the capabilities, what grid forming can provide to the system. And as well, we understand that every system is different, so they don't need all the capabilities because it depends on what are the needs. So we help as well to identify what are the needs, and according to those needs to define what are the technical requirements that they need for grid forming. So it was the case as well in Coordinador Eléctrico in Chile, where we help with this information and they propose like the technical requirements for grid forming. And as well, we help the system operator in Brazil, ONS, to defining those particular capabilities according to their needs. And in Colombia, we help them to review the grid forming requirements that they were developing. So this work that we developed with ESIC is helping several system operators. We have several requests for the same topic. So probably in the next years, we have been working with more system operators, helping them to define grid forming requirements. So for the grid forming as well, we have the technological council. So basically for this council, the goal is overcoming the challenges of commercializing grid forming inverter-based equipment and accelerating its deployment. So the action is bringing together system operators, OEMs, project developers, consultants, software developers, and standard bodies that they can understand what are the capabilities, how grid forming can behave in the system, how they can use, how they can test, because at the end, it's not only the technical requirements. It's very important to include what is the testing and to verify that those IBRs can provide the services that they are supposed to provide and the system are requiring. So this is something that we are developing, and this is like with the energy system integration group. Regarding system needs and services, so it's very related to the work that I presented before regarding stability and regarding a grid forming. So basically for all of them, we are reviewing what are the needs of the system. So I start with the needs, and after that, what are the services that they need. So some examples are, for example, system strength. So it's one of the needs in Colombia, in Chile, in Brazil. So we have been working in one tool for defining what is the system strength in the control room. It was in cooperation as well with Colombia and Chile. It was a project that stopped, but we hope to continue soon to finish that. Regarding inertia, as I mentioned before, so we have been working with India and as well with South Africa, helping them to understand what is the inertia that they have in place and what are the needs for the coming operation. Regarding resource adequacy, it was the example that I present in Grid India. So it can help them to understand what are the needs for the system in future, what is the energy that they need, how they behave according to the new resources that they have with solar, with wind, so how they can behave in the coming years and to support the demand that they have for the coming years as well. So another way that we work is like in community of practices. So here I have an example how we work in Latin America, helping the system operators that are part of RELAC, helping them to understand and to train them regarding how to operate with IBR. So for that particular training, we developed several sessions, and after that we have one in training in person in the National Lab of the Rockies, where we were helping like system operators, regulators, ministers, government entities to understand how they can use IBRs, how they can operate in a secure way with IBRs, what are the studies, forecasting, what are the technologies that they can use, for example, with grid enhancing technology. So we developed like a detailed course with RELAC and also with several partners that we have in the bottom of the slide, where we help those system operators understand what are the best way to proceed regarding IBR integration. As well, we developed something similar in Southeast Asia with ACE. So we don't have the example here, but last year, for example, we developed an in-person training in Manila where we were helping system operators in all Southeast Asia to understand also how they can plan with IBRs, how they can use the storage, and also how they can coordinate between countries in order to improve flexibility. So those are some of the examples how we can help and how we will be helping during the last 5 years across the globe. The last topic, so is distributed energy resources. So as I mentioned before, for this topic, we are not focusing distribution, we are more focusing the bulk power system, how the ER are like impacting the bulk power system, and also how the ER can help the bulk power system. So for that, we developed some workshop, webinars, and peer-to-peer learning on the ERs in Vietnam, for example, as well in Panama, helping them to understand the IEEE standard 5047, what are the requirements, what they need regarding that. As well, we help in Colombia with some webinars with the system operator and the regulator, helping them to understand what is 1547. And also for India, as this is a 50 Hz system, we help and we cooperate with IEEE to develop like the standard for 50 hertz power systems. And at that point as well, the National Laboratory of the Rockies was helping with that particular assistance. So I want to thank you for the time, for being here, for like also for all the work that you have been doing. I know that several research entities and system operators are connecting here. So this is the work of you, the cooperation of all of us. So if you are not like engaged with G-PST and you are working in some of the topics that I present, we are like happy to receive feedback or cooperation. So we are happy to be part of G-PST, to having you in G-PST. And yeah, as Gabriel mentioned before, if you are a researcher and also if you are starting, so it's helping a lot because you have more energy, more like interest to work in some of the topics. So happy to hear from you and could be in the research agenda or in the technical assistance. So yeah, welcome all the questions, feedback, and cooperation in future. And thank you everyone for being here and for all the cooperation during the last 5 years. Karin, I think that
Excellent.
I
Thank
pass
you
over
very
to
much.
you.
Great. Thank you. And yeah, that was fantastic. Just an absolute worldwide tour of the different examples of the work that G-PST has been engaged in over the last several years, and also the deep dive into the research agenda. So thank you both, Lena and Gabrielle. We have a couple questions in the Q&A area. So I think we'll probably go through this and wrap up at the top of the hour. Oliver Probst asked specifically about whether there are efforts to instate reporting obligations for data centers with large load variation. So given that electricity load closely correlates with the computational load, it might be possible to anticipate jumps in power consumption based on the computing pipelines of the algorithm. So I have a thought on this, but Gabrielle, do you have anything you want to share in thinking about this question on data centers and the reporting obligations?
Well, considering like the data centers, I mean, there have been very, very recently that system operators are trying to establish like a consensus of what are the technical requirements for right through and everything. So I think like since it's like a very recent problem, there's like not a real consensus. And well, in considering also that it really depends on the jurisdiction and like really the system operator interests, it will take a while until say that there's like some fixed constraints for data centers. I don't know if you want to add something, Karen.
Yeah. Great, thank you, Gabrielle. Yeah, this is 100% an area that system operators are watching very closely, right? This is the volume of loads that we're talking about, and the possible fluctuation is something that we don't have a lot of precedent for operationally. I was just going to mention some examples, and then I see Lena's got her hand up too, so she can follow up. I put into the Q&A answer, so hopefully everybody can see that, just a link to our friends over at the Energy Systems Integration Group. They have a large loads task force that is looking at a number of different dimensions of large load, and performance and monitoring are one of those dimensions that they're exploring. We have a project at the National Laboratory of the Rockies that's focusing on both the modeling and control of the dynamic behavior of large loads. And as part of that project, the team there, and interestingly, the team there is one person, Shahil Shah, who is leading that, who has also worked on grid impedance scanning for oscillation detection, and then Jin Tan, who supported G-PST in developing some new approaches for inertia monitoring. So a lot of different topics that are loosely related. And in this project, another team member, Andy Hoke, is supporting by keeping an eye on some of the different efforts that are looking at regulation and obligations for large loads. So NERC in the United States has a group or task force that's looking at different regulatory approaches and what kinds of performance specifications reporting obligations should be put in place. And I know this is an area that maybe the US has a lot going on and more data center load coming online, but also the entities that regulate in the US are looking around to see what examples they can come up with from other inverter-based resources and what those obligations or specifications should be. Lena, do you want to go ahead and add something there?
Yes, I want to mention that with the EPICS project, we are working as well in the National Lab of the Rockies regarding that topic, trying to simulate in the Siena tool the load, the big load. So for that, we are trying to understand where's the information that we need, working with several load centers. So basically, in the coming months, maybe we will have more updates. And as well, we are working with Imperial College in that topic. So yeah, we are working on that, and we are happy to receive like feedback or yeah, to improve according to the experience of the public here. Thank you.
Thanks, Lena. And Mark O'Malley noted in the Q&A that he could answer more about Oliver's questions. So I told him maybe he could put some more information in the regular chat in detail. So Oliver, you can also look over there. Sasha Eschman asked, I may have missed it, but did not see or hear anything about AI or robotics. And I wanted to mention that there's another project that one of our team members, in fact, the person Lena was mentioning who led a lot of the work in partnership with Vietnam and DER is actually historically worked in control rooms and reliability, and he has a lot of research looking at control room of the future, control room approaches, and specifically different emerging ways of using AI that could be relevant for power system operators. So he's got a project going on right now. He works at the National Lab of the Rockies, Song Choi, and he is looking at ways of using AI to manage alarms in the control room. There's another colleague that we have over at EPRI who is working in the Alarma project that EPRI has going on that is looking at using AI for control room alarms. But there are definitely, a number of different projects and initiatives. I would say AI is something that system operators have been paying keen attention to, and as a group of people who are entirely responsible for the power system reliability, want to see what's happening and understand how it can benefit, but also want to take a cautious approach to putting entirely new ways of using AI into the control room. And so that's something that we directly addressed as an emerging area to keep an eye on in the research agenda. And that's something I would expect that you'll see us doing a couple webinars this year that touch on this as part of other topics. You're welcome. There's a question regarding system strength. What metrics or approaches are you using to evaluate this? And Lena, I think maybe this is something you could comment on a little bit in the approaches you thought about with the project with RTPA and the system strength tool.
Yeah, sure. So we have two ways to track the system strength in the control room. So one of them is using PMU data. With that, we are using the turning equivalent, and it's different to the static turning equivalent because at that particular time, if we are using PMU data, that is something that is like alive, so it's not fixed as is in the planning study. So this is one of the approach. And the other approach is tracking more the voltage, so relating system strength according to the voltage changes and variations that we are having. And basically everything is using PMU data.
Excellent, thank you. We're almost to the top of the hour. I saw that both Mark O'Malley and Thomas Brinsmead put some additional information into, it's like Mark put an answer into the Q&A, and then Thomas had a question around in a recent study comparing IBR technical requirements in Chile against benchmark technical requirements, to what extent were the recommendations and gaps identified of a universal nature, and to what extent were they specific to Chile, Lena? In the case of the latter, are there particular aspects of the national context that are most relevant to nationally specific technical requirements? If you want to give a quick answer, and then I will wrap us up.
Yeah, I think that this is a good question. So basically, we work really close with the system operator in Chile. So they identify the needs and the problems, and we help them to see what are the technology evolutions. So one example is phase jumps. So they were not like requiring that in the grid code, and this is something that they need according to the studies. Current injection as well from IBRs, it was like with a requirement very low compared with other standards are R2P 2800. So they were proposing something to improve that according to the technology evolution. And regarding voltage right through as well, reactive power, so were some of the examples that I can mention how they can improve. And as I mentioned, it's according to the technology evolution and also the needs of the system in Chile, because it was developed, the sites were developed by the system operator.
Perfect, thank you. And I think that you all can see the questions that other people have asked or answered in the Q&A section, and then also over in the chat. And Mark reminded me here, this is one of the things where you're answering a question live and you forget something very obvious. We did run a 1-week workshop in Edinburgh at the beginning of the year before last, specifically focused on the topic of AI and power systems, and brought together a number of operators and researchers to identify the key key priorities, and advance some of the projects moving forward. So there's something on topology optimization that has come out of that, and other questions that different research teams and research and operator teams have been working on. So happy to share more of that at future events where we're looking at different AI approaches for managing power systems. So stay tuned, we'll be sending that out. The last thing I wanted to mention, someone asked specifically about whether we will share the slides. And yes, we will be sending out a link to the recording, and the slides will be posted at that same link to everybody who registered for this event. And then we also will highlight this in the next newsletter, so everybody on our whole distribution list will get that. So in closing, thank you all very much for making the time to join us and to participate in a conversation about the first 5 years of G-PST. It's been a great ride. We're really looking forward to seeing what is next and seeing all of you more, hopefully, in 2026. Thank you and have a wonderful rest of your day.
Thank you. Bye.
Thank you all for attending.